Okay, so we have just started talking about what a radian is. So we talked about coterminal. We talked about the fact that you can have positive and negative angles. You good? Okay. Okay. Anyway, we're talking about coterminal angles, the fact that angles can be formed by motion, so you can have angles. Stop talking, please. So you can have angles that are more than 360 that are negative because that indicates direction. And then like I said, we were just talking about radians. So a radian is what happens when you take the radius of the circle and you stick it on the outside edge. This much is 1 radian. Okay, that angle in there is 1 radian. And so then we were talking about the fact that there are, looks like 6-ish radians in 1 circle. Is related to the circumference. So the circumference is 2 pi r. So we talked about the fact that there are 2 pi radians, 2 pi r in 1 circle. There are also 360 degrees in 1 circle. It's that information that's the foundation of how we will switch between degrees and radians. Okay, so radians, a couple things that you got to know. Radians are always written in terms of pi, and they're always fractions and not decimals. Okay, that's super important. So we're going to start out by talking about converting between degrees and radians. That's where we're going first. And we're actually going to start radians to degrees because that's easier. And this is the one actually that's most useful because most of the time, if you're given a radian and if I was like, hey, what quadrant is this in? Yeah, I don't think in terms of radians. I can do it if I stop and think about it. It's easier to just turn it into terms of degrees, and then it's easier. So I said, you don't have to write this down, but 2 pi is equal to 360. 2 pi radians is equal to 360 degrees. So that means 1 pi radian is equal to how much? 180, because you can divide those by 2. So we use this information that pi and 180 are interchangeable. So for example, this is how you would write a radian. Like, for example, pi over 6 is radians. That's just what it looks like. That'd be a radian measures in terms of pi. So the way that we convert that is we replace our pi with 180. So that jumps us back into degree mode or to degrees. And so it would be 180 divided by 6, which is 30. So pi over 6 is equivalent to 30 degrees. So it's super easy to convert radians to degrees. You simply replace the pi with 180. So let's say we have 7 pi over 5, also how you would write radians. Okay, that's a fraction, no decimals, so it's not 1.4 pi, it's 7 pi over 5. So how many degrees is that? Yeah, 252. So you do 7 times 180 and you divide by 5. 252 degrees. Now, 7 pi over 5, I can, like I said, I can think about where that would be and I can make a pretty good guess, but I know where 252 degrees is. It's down here in the third quadrant. Here's 180, here's 270, so 252 would be here-ish. Okay, so this makes way more sense to my brain. And I've been doing radians a long time. So sometimes people are like, yep, I'm really good. Sometimes people are like, nope, no thanks with radians. Let's do 9 pi over 4. 9 pi over 4 radians into degrees, please. What is this? How many degrees? 405. Okay, last one because it's really not that hard. Let's go. Pi over 12. Is what? 15 degrees. Okay, so it's very easy. Radians to degrees is the one that I use most often. 180 is equal to pi. You can swap them in and out. Now, degrees to radians, a little bit more complex, but not difficult. So to do degrees to radians, let's say 400 degrees. Ugh. 400 degrees, we're going to convert them to radians. What you do is you multiply by the fraction pi over 180. Okay, now let me tell you first of all why you can do that. Pi and 180 are equal to each other, so pi over 180 is 1. So you're multiplying by 1. You multiply anything by 1, it's equal. So what you do with this then, because we want it to be in terms of pi, you reduce this in your calculator or in your brain. You can reduce it in your brain too. But remember, your calculator will do that for you. So you have, just a second, I'll get out my actual calculator for you. Here you go. Second, and then the guy next door with the X, not second, alpha with the X. And then you type in 400 and then you type in the 180 and you hit enter and it will tell you that it's 20 over 9. So this guy, yep. So this guy is 20. You just slap the pi back on then, 20 pi over 9. So you reduce the fraction and the pi goes on top, basically is what you got going on. Okay, so then let's do, let's do 240 degrees. Okay, so multiply by pi over 180, reduce your fraction. What's the fraction itself reduced to? Yep, so then this is 4, and you put the pi back on. So 4 pi over 3. To reduce the fraction, put the pi back on. Now, here's what I would like you to do. We're going to practice that because that's the one that's harder. So on this paper, I would like you to, if you're well, let's do this. 240 degrees, we just did that, is 4 pi over 3. So I'm going to put him on that other blank in there is for 4 pi over 3. Okay, we also, if you were taking notes, we also have 30 degrees in our notes already. 30 degrees started out as what? Pi over 6. Maybe that's for a fraction. So we'll do this. 0 degrees would be how many radians? 0. 0 is 0. Okay, so 45 degrees multiplied by pi divided by 180. So you're going to, oops, sorry, there you go. You're going to divide that in your calculator, 45 over 180, and reduce your fraction. Is what? Pi over 4. 1, so it's 1. So 1 pi over 4, you don't need the 1. Okay, I would like you to get all the rest of those. If you are not confident, either use pencil or put them on your paper, and then as we go through, you can make sure you have them written down. Okay? Yes, it was. Okay, so if you're not done, that's okay. Just make sure you get them written down. 60 degrees is what? Yep, pi over 3. 90 degrees. Pi over 2. Guys, that should make sense because we know that 180 is pi, so 90 is half of that. So it's half of pi. Javon, what'd you give for 120? Okay. Weston, what'd you give for 135?
3 pi over 4.
Okay. Grayson, what'd you get for 150?
5 pi over 6.
Yep. What's 180? Yeah, pi. Okay. Christian, what'd you get for 210?
7 pi 6.
7 pi over 6. Andy, how about 225?
5 pi over 4.
5 pi over 4. Okay. 270. Trevor, did you get 270? 3 pi over 2. 3 pi over 2. 300. Connor, what'd you get?
5 pi over 3.
5 pi over 3. Larkin, what'd you get for 315?
5. 7 pi over 4.
Yep, 7 pi over 4. Kira, what'd you get for 330?
11 pi over 6.
Yep, that's right. 11 pi over 6. Okay. Levi, did you get 360? It is 2 pi. There you go. Okay. So this is really nice because we will be operating in degrees and we will be operating in radians. So now you have, these are the main 12, 13, 16. These are the main 16 ones that we use all the time. So it's nice to have them here. Directly converted, you don't have to do it again. Now, last couple things we need to talk about today are very much geometry related. So a little bit trip backwards to geometry. So we are going to talk about arc length. And then we're going to talk about linear speed and angular speed. Okay, none of these concepts are difficult. Okay, they're all formula based. They should be pretty easy. So a couple things that you need to know, a couple circle terms that we have here. Not such a good circle. So if you have a radius and a radius, the part of the circle on the outside is called the arc. Okay, so if it's on the circumference of the circle, it's called an arc. If we're talking about the measure in here of the angle, it's called a central angle. Okay, and those two things are always the same. Like whoever decided how we do this, like those are the same. So the central angle is the same as the arc. So if this is an arc of 40 degrees, the angle is 40 degrees. If the central angle is 120 degrees, then the arc is 120 degrees of arc. So it's weird that arc is measured in degrees, or even radians sometimes, but we want to turn that into actual length. Like it needs to be measured in inches or whatever. So your first formula is a formula for arc length. And arc length is the perimeter of the circle times the fraction of the circle traveled. Okay, and if you don't know the formula for perimeter, it is up on the posters, but it's 2 times pi times r.
But we have to memorize it.
No. So here's an example. So let's say the radius of a circle has a radius of 4, and we want to find the length of the arc intercepted by a 240 degree angle, central angle. Okay, so if I was going to draw you a picture for this, the radius would be 4. The central angle would be 240 degrees-ish, which, somewhere in there. So we are looking for what is the length of this section of the circumference. Arc length is just the fraction of the circumference, basically. Okay, this is 240 degrees. So we take the circumference of the circle, which is 2 times pi times 4, so 2 pi radius, and we multiply by the fraction of the circle. So that's 240 degrees out of how much? Yeah, 240 over 360. And you multiply them together. And this can be absolutely in terms of decimals, because we're talking about, it says the radius is 4 inches, I think. I didn't put that in my question. So we're working in terms of inches. Okay. What do you get? 7.6, but yep. Because it's 7.55. No. Okay, 16.76. You literally, here's the perimeter, 2 times pi times radius. Here's the fraction of the circle, 240 out of 360. Okay, let's do another one of those. Okay, so same question. Circle has a radius of 27 centimeters. Okay, there you go. So the circle has a radius of 27 centimeters. Find the arc length if the central angle is 160. Okay, what do you get? Yep, 75.4. And that would be centimeters because this is centimeters. So circumference 2 times pi times radius times the fraction of the circle, which is 160 out of 360. Now listen, what if what if the radius was 10 and the central angle was 2 pi over 3? Okay, you got two options. 2 times pi times radius, right? That's normal. You could do 2 pi over 3 over what's the whole circle in terms of radians? In terms of radians, though. You could just put the 2 pi there and do it that way. You can do a double fraction on your calculator. Okay, so if we were going to do this on our calculator, you could do 2 pi, no, shoot. Pi, there you go, times 10. So double fraction would be here, and then not that. Crap. There you go. You gotta put the times on though. Times, here you go. Fraction, and then you can do your fraction again. So you can double fraction that. There's your 2 pi over 3 over, yeah, it is, over 2 pi. Or it's probably faster to convert it to degrees, but it's 20.94. Okay, or you can convert your 2 pi over 3 to degrees pretty fast and do that over 360. But just because it's radians doesn't mean you can continue to work in radians, so that's okay. Okay, so linear speed and angular speed. So imagine that you're looking at a clock, like an old analog clock that has a second hand. Okay, so the second hand, the end of the second, here's the second hand, and it's traveling. That's not the way it's traveling. Good, because it was wrong. Okay, it's going this way because it's the second hand, right? Okay, so it's going this way. Let's say the second hand is it's a big clock, so it's 10 inches long. So the second hand travels once around every minute. That's the way it works. linear speed, linear speed is actually like the very end of this. How fast is the end of it going? Okay. Angular speed is how fast is this angle. So here, you would measure from here. How fast is that angle changing? Okay. So linear speed is how fast something on the edge is changing. So this would be a point on the edge of the circle. Okay, and angular speed is actually the angle, because that should make sense. Okay, is the angle. So linear speed, the formula for linear speed is the arc length divided by the time. So you have to go back and do the arc length formula to get this. Angular speed is the central angle divided by that time. So angular speed is much less work. Okay, so I don't like that question. Okay. So let's say it's our clock anyway. If we're going to find the linear speed of this is actually really easy. Linear speed would be the arc length, so the whole thing all the way around, because we're not measuring off just a little bit. Okay. So the arc length would be 2 times pi times 10 times the whole thing, which is 360 over 360. So you don't even need it. Divided by the time. What's the time it takes to go around? 1 minute or 60 seconds, right? So let's go 60 seconds. So 2 times pi, don't need that because we only went once around. That's equal to 1. And then divided by 60. So this guy right here travels, I got 1.047. And that is inches. I know it's inches because I'm working in inches per second. That's how fast. If you were measuring a second hand, that's how fast that guy's going around the edge, the outside edge. 1.047 inches per second. Okay, now his angular speed, if this is kind of dumb, but whatever, we'll do this in seconds. How many degrees does it go if it goes once around? 360. That's not difficult, right? 360 out of 60 seconds. So what's his angular speed? 6. And that would be degrees per second. So as that second hand is going, he's going 6 degrees every second, all the way around. Okay, so let me give you one that's a little bit different here. So let's not do a clock. A clock's always 60 seconds, which is kind of boring. So let's say you've got a big wind turbine. Right, so they look like that. And so let's say this guy is rotating 12 revolutions per minute, and his blades are 120 feet long. Okay, let's find the linear speed and the angular speed. And this is going to be the linear speed of the blade tips. Okay, so this is not hard. You're just going to go once around. So you can figure out that's the circumference. Right? So 2 times pi times 120. If we go once around, how many degrees is that? 360 out of 360. So honestly, don't even need that part for this problem. But what's the time for that? 5. Right? Because it's 12 revolutions per minute. So the time would be 5 seconds to do that. Okay, then you can math it out. 2 pi 120 divided by 5. So 150.8 basically. 150.8 feet per second. That's really fast. Okay? 150.8 feet per second. Super fast. Okay? Now, let's talk about the angular speed. Okay? Angular speed would be how many degrees? We know once around 360 degrees. In how long does it take? 5 seconds. I think it's 72. Okay, so that's moving 72 degrees per second. 72 degrees of rotation per second. Now, just for the sake of weirdness, it's very fast. Just for the sake of weirdness, I want you to know if you went at a point that's only 30 feet out on the propeller blade, it's moving slower than the guy at the end, which is weird. It's on the same blade, but it's actually moving slower. Its linear speed is slower and its angular speed is slower. Angular speed is the same, I lied. Correct. Yep. Okay, so that is all I have for you. Those ones are not super vital, but they're good for your brain. So we're gonna do it. No, that's all of it. I didn't think that we'd get through all of it, but you guys probably can get this done in 15 minutes. No, I actually. No. Javon, if you would spend less time whining, you would get the homework done.
Ooh. I mean, I can whine